Okay, so for this video is going to be just a bit longer than the previous ones just because there's just so much stuff that we have to find, work out, convert, and yeah, so let's just get started. Like always, whenever I solve my problems, I like to do my t-table. Okay, I like to write my what I know and what I don't know. So my knowns and my unknowns. So what do I know? Well, I know that I'm given. Oh, first let's read it. The inner and outer surfaces of a 0.5 centimeter thick 2 meter by 2 meter window glass in winter are 10 degrees Celsius and 3 degrees Celsius respectively. If the thermal conductivity of the glass is 0.78 watts divided by meters Kelvin, we have to determine the amount of heat loss through the glass over a period of 5 hours, and then we have to change it up and we have to find what would it be if it was instead of 5 centimeter 0.5 centimeters a 1 centimeter thick. Okay, so first things first, let's go with this one. Thickness is 0.5, so let's change that. So I know that's going to be my L or thickness, and that is 0.5 centimeters. I'm gonna change it up to meters. If I do that, this becomes 0.05 meters. Okay, all right. Now I'm giving my area 2 meter by 2 meter. So I have 2 meters times 2 meters, which is going to give me 4 meters squared. Also, the window glass in winter are 10 degrees and 3 degrees respectively. Just like I said in the previous video, I'm going to change those into kelvins. We can do so by adding 273 to this one, 273 to this one, and then when you subtract them, you still get the same answer. You still get 7 degrees Celsius, right? I mean, you will get 283 and you get 276. You subtract them and you still get the 7 kelvins, right? So 283 minus 276, you get kelvins. Okay, so this would essentially be in kelvins. So my delta T, I am just going to put it as 7 kelvins. Okay, I'm also given the thermal conductivity of the glass, which is 0.8 watts divided by meters Kelvin. So thermal conductivity is equal to 0.78 watts meters times Kelvins. Okay, for my unknowns, this is right here the amount. Okay, that's what I'm looking for. We know that we have this formula, Q equals what? MC delta T. But would this help? No. We do know that we are going to be using a formula in which we're given thermal conductivity and where we also have the thickness, which is this one. Q dot is equal to thermal conductivity times the area times change in temperature over the thickness. But wait a minute, how is that gonna help us out? Because at the end of the day, we want the amount of heat loss. We don't want the rate. This here is the rate, right? Well, if we think about it, we also have this other formula. Q dot is equal to Q over delta T. This is another well, actually this is the rate of energy transfer, right? The rate of energy transfer is just the amount. Okay, this is the amount of energy or heat loss divided by time. Okay, so then what we can do is that we can actually substitute a couple of things. Okay, there's different ways on how you can approach this guy. Okay, one of them would just be using this formula. Well, okay, let's do this. Let me solve this. Okay, so I have q dot equals to q over delta t. Again, rate of energy transfer equals to the amount. Okay, this is the amount, this here, of heat loss over time. I wanna isolate this one. Okay, I wanna isolate it. I wanna leave it by itself. In order for me to do so, I have to multiply both sides by delta t. Algebra, right? So if I do that, this cancels out with that one, and I end up with delta t times my rate of energy transfer, which is equal to the amount of heat loss, which is what I'm looking for. Okay, that's what I'm gonna be doing. Okay, so let me continue over here. I also have the time, 5 hours. Okay, I need to convert that into seconds though. Okay, would it matter? I don't know, let's try it out. So how do you go from hours to seconds? Well, one way to do that is that you write your 5 hours. Okay, and you want to go all the way to seconds. So whenever I'm doing unit conversions, no, it's called something different. I forget right now, but let's just go converting from 5 hours. I write down my hours on the denominator because I want them to cancel out, right? These hours are on the top, these ones are on the bottom, so they cancel out. So then I'm gonna put minutes. I know that I have 60 minutes in 1 hour. Now, I want to go from minutes to seconds. So what I need to do is that I need to put minutes on the denominator and put seconds on the top. I also know that I have 60 seconds in 1 minute. So now what happens is that the hours cancel out with these hours, minutes cancel out with these minutes, and I'm left with seconds. Okay, so once you multiply 5 times 60 times 60, you're gonna end up with 18,000. So my delta lowercase t is going to be 18,000 seconds. Okay, what else do I need to know? No, I think that's it. Oh, the other one. Let me convert this right now. That's gonna be for the second part. In this case, I'm given that's 1 centimeter. But again, if I divide by 100, that's just going to become 0.01 meter. Okay. So now I can get started on this one. The first thing that I'm gonna do, I'm gonna use this formula. Okay, I'm gonna use this formula. I'm gonna work it out on its own, and then I'm gonna get an answer. Once I get that answer, I'm gonna plug it in here, and then I'm gonna multiply it times this time, and I'm gonna get what I'm looking for. I should have enough space. So let me keep things a little bit organized. So I'm gonna start over here. So my Q dot is equal to thermal conductivity times area delta T over length. Okay. So when I do that, Q dot is equal to thermal conductivity 0.8 watts divided by meter Kelvin. Okay. Area, it was 4 meters square. Okay. Now, change in temperature, we said that it was 7 kelvins. Thickness, it's going to be, for this first problem, 0.05 meters. So 0.005 meters. Let's cancel out units. Kelvins cancel out. I have 2 meters here. Okay. If you want to see it, that's meter times meter, right? Meter times meter is meter square. So one of these cancel out with this one, and then the other cancels out with that one. Therefore, I'm left with those watts in there. Okay. To do the whole math, 0.078 times 4 times 7 divided by 0.005. So then what you get at the end of the day, once you do all of that, is going to be 4,368 watts. But you have to remember that these watts are actually joules per second. Reason why we had to go and convert these hours into seconds, because that's what's gonna cancel out once we use this formula. Again, use your units. The units tell the entire story. So then I can rewrite this as 4,368 joules per second, right? So for my first part, Q equals to Q dot times delta T, right? Well, I already found Q dot, which is this. So Q equals to 4,368 joules per second. And this is multiplied by delta T. Delta T, well, lowercase t that is, was 18,000 seconds. My units cancel and I'm left with joules. We know that the amount of energy transfer is going to be joules, which is what we expect, right? So when you do that, you end up with a really big number, 78,624,000 joules. And you can change it into uppercase M J. Okay, I'm not going to do that. I want to move on because now I want to try it out with that one, which will be the second part of this problem. So I'm essentially going to do the same thing. I'm going to use the formula Q dot is equal to Ka delta T all over thickness. Okay. So essentially everything's going to be the same except for the thickness. So Q dot is equal to 0.8 watts divided by meters kelvins times 4 meters square times 7 kelvins. Now this here is going to be 0.01 meters, right? So once you do that, well, okay, let me cancel out the units. Kelvins cancel out. One of these meters cancel out with this one. The other meters cancel out with that one. And again, end up with watts or joules per second. once you multiply all of this out, you should get I believe is 2184 joules per second. Notice how I'm transitioning from watts to joules per second in here just so that I can save one step. Now I'm gonna apply it to the same formula. So Q equals to Q dot times delta T, which just turns out to be 2184 joules per second, time still the same, 18,000 seconds. Seconds cancel, and then your final answer will be 39 million. Okay, again, another big number. You can go ahead and convert it into joules. I'm not going to do that. I think this video is long enough as it is. Okay, so those are going to be your answers. Work it out a couple of times. Make sure you understand it. Make sure you know what you're doing. Okay, I think it was pretty straightforward. There it is. You have the answers right there to double check. Okay, all right, that's all.